Hello and welcome to the screencast for my third year project called Learning the Student's Happiness Model. The first main objective of this project was to identify the mathematical relationship between a set of individual happiness factors and the overall happiness level of a student using machine learning techniques. The second objective was to compare the importance of these factors between several groups of students, for example, males and females, or students who are studying computer science or medicine. Finally, the last objective was to predict the student's happiness based on these factors as accurately as possible using machine learning models. Let's take a look at the data set which was selected for this demonstration. It is composed of 83 female students, and this data was extracted from the results to a questionnaire designed by the student in one of the earlier stages of this project. Each one of these 83 female students is described by how happy they are with 13 different aspects of their lives on a scale from 1 to 5. These aspects include, for example, their health condition, their relationship with their family, or their satisfaction with the course they are studying. They are also described by a happiness index on a scale from 1 to 10, which indicates their overall happiness level. Now let's take a look at some of the algorithms which were used on this data. The first one of these algorithms is linear regression, which was implemented in Java using the Weka API, Weka being a software tool that contains a collection of machine learning algorithms. Linear regression is very useful for the objectives of this project because it estimates the importance of each one of the 13 happiness factors to the overall happiness level. It is also able to predict the happiness indexes of students, although it is not the most accurate algorithm to do so. Let's see how it works. The first step is loading a dataset, which in this case is the female dataset. The second step is to select the parameters of the algorithm. We can now run the algorithm and see the results. These come in the form of three tables. The first table is called the predictions table. Its first column contains the true happiness indexes of the students, the ones with which they had responded to the questionnaire. The third column contains the predicted happiness indexes, the one that linear regression predicted. The fourth column contains the absolute difference between these two, and the final column contains the same differences but expressed percentage-wise. The second table is called the linear regression equation table, and it indicates the most important factors for this student group. For example, in the case of female students, the most three important factors are self-esteem, making others happy, and health condition. The third table is called the statistics table, and it contains a few measures of accuracy. For example, the mean absolute percentage error relates to how far away the predictions made by the linear regression model are from the true happiness indexes of the students, while the correlation coefficient indicates the strength of the relationship between the 13 happiness factors and the overall happiness level. Another algorithm that was implemented in Java was the multilayer perceptron, which is much more complicated but also leads to more accurate predictions. Once again, we load up the female dataset. Then we select the algorithm parameters, which are more in depth in this case. We can now run the algorithm and look at the results. There are only two tables now, the predictions table and the statistics table. It can be noticed that when compared to the linear regression results, the mean absolute percentage error is lower and the correlation coefficient is higher, which means that the multilayer perceptron is performing better. Finally, a third algorithm was implemented in Java, the sequential minimal optimization regression, but its functionality is quite similar to the previous two showcased here, so it will not be shown. Let's take a look at a different approach, a classification or regression tree, which is used directly from Weka. First, the 83 female students are split into three groups. Those with happiness indexes between 1 and 4 are unhappy, between 5 and 6, neutral, and between 7 and 10, happy. The goal of this tree algorithm is to classify the students into these three groups as accurately as possible and to highlight the individual happiness factors which determine these classifications, thus reinforcing the results from linear regression. Let's run it and see the results. It can be seen that 72 out of the 83 students were correctly classified into their corresponding group and 11 were not. Now let's take a look at the tree of happiness factors that was created by this algorithm. The two happiness factors at the top of the tree are make others happy and self-esteem. There are 6 female students who do not consider that they make others around them happy, and they are labeled as unhappy themselves. However, there are 44 female students who do believe they make others around them happy and also have good self-esteem, and they are labeled as happy. This reinforces the results from the linear regression model, where make others happy and self-esteem were two of the most important factors for determining the overall happiness of a female student. Finally, let's take a look at all of the results collected through the use of these algorithms. This table shows the individual importance of each of the 13 happiness factors towards the overall happiness level of a student from different groups, such as female, male, UK students, or international students. This fulfills the first objective of the project. Moreover, we can compare the importance of happiness factors between different groups of students, for example, female and male students. For females, self-esteem is more important for their overall happiness than it is for males, but also they are affected negatively by physical appearance more so than males. These collected results enable comparisons of this type between several groups, which was the second objective of the project. We can also compare the three algorithms which were implemented, namely linear regression, multilayer perceptron, and sequential minimal optimization regression, in order to find out which one predicts the happiness indexes of students most accurately. This can be done by using the mean average percentage error, and as can be seen from this table, the multilayer perceptron is the most accurate in most of the student groups that were analyzed. This was the final objective of the project. Thus, this screencast has demonstrated how the main objectives of this project were completed.